Greetings everyone. Welcome back to the course Mechanics of Road Vehicles. We are discussing about CO number 4, analyze the tractive characteristics of vehicle for different types of drive. We are in unit number 4, vehicle performance. The topic of resistance and tractive forces. Our specific outcomes, what we are going to learn here are determine the power required to propel the vehicle. How much amount of power is actually required to propel the vehicle in desired direction. We have to calculate the amount of power and amount of torque and also the force required to propel the vehicle. Second outcome is analyze the various resistive force act on the vehicle. We know that there are lot or many number of forces that may oppose our movement. In vehicle movement also there are some sort of forces will affect the movement. Here we have to learn the number of forces and the nature of the forces that actually opposes the movement of vehicle. That is we called resistive forces on vehicle. Resistance of vehicle. The vehicle may experience different types of resistive forces during the movement or motion. Here we listed three major resistive forces which importantly or majorly affects the movement of vehicle. First one is air resistance. Second, rolling resistance. Third, gradient resistance. Gradient resistance may generate because of movement of vehicle on slope. First one is air resistance. Let us have a simple example here. We have two containers, one is filled with air, another one is vacuum, there is no air. In vacuum, if you drop any two components, it comes quickly without any hesitations. But in air, here you can note the paper component is floating on the air because the air particles produces resistive forces against the movement. So during the movement of vehicle, the air particles around the atmosphere produces the resistive forces against the movement of vehicle that we called air resistance. Air resistance is the resistance offered by the air to the movement of your vehicle. Right here, force against vehicle movement because of air. The performance, ride and stability of vehicle depends on the size and shape of the body of vehicle. So that here the area of vehicle majorly influences the air resistance. I mark it as influence parameter. And also speed and wind velocity affects the resistance. It may increase or decrease the amount of resistive force. So vehicle velocity also plays major role in air resistive force generation. The last term should be taken into the account when indicated, otherwise it can be neglected. Hence, in general, air resistance RA we can say with the use of influencing parameters frontal area that we called A velocity V, so that air resistance RA equal to KA square, because air resistance directly proportional to area or frontal area of vehicle, and air resistance directly proportional to square of velocity of vehicle. So RA directly proportional to AB squared, RA equal to KA squared. Here RA is air resistance indicated in Newton. Ka is coefficient of air resistance. If the vehicle is streamlined body, so that air resistance can be reduced. So if it is a streamlined body, air resistance coefficient will be very minimum. That may be 0.023 if a vehicle is streamlined. For average car, we take it as 0.031. If a vehicle is a bus or truck, the air resistance coefficient is 0.045. V indicates velocity of vehicle, A indicates frontal area. Frontal area measured in meter squared, velocity of vehicle measured in kilometer per hour. In vehicle performance unit, it is very much important to note the unit of parameters. Instead of indicating in kilometer per hour, if you indicate the velocity in meter per second, you will get wrong air resistance value. So that unit plays major role in the calculation of vehicle performance parameters and resistive forces. Second one is rolling resistance. In this picture, you can see the tire is rolling. Because of rolling on the road surface, there will be some sort of resistive force will act on the contact surfaces of tires. The resistive force generated because of rolling, so that we call it as rolling resistance. There are a number of factors which affects the rolling resistance of vehicle. The magnitude of rolling resistance depends mainly on the nature of road surface, types of tire, it may be bias ply tire or radial ply tire, weight of the vehicle, and speed of the vehicle. So rolling resistance directly proportional to road surface, directly proportional to weight of vehicle, rolling resistance, and also directly proportional to velocity of vehicle. Rolling resistance, we can say R equal to A plus B, that is constant values into velocity of vehicle v whole bracket weight of vehicle w. Velocity measured in kilometer per hour, weight measured in Newton. A value, maybe we take it as this is a constant value, so that I just give 0.015, b is equal to 0.00016, so that this value get minimum. We can simplify this formula r equal to kr into w, because b value is very minimum, it is 0.00016. Even velocity of vehicle increases, there we get minimum range of value, so we give rr equal to kr into w. I just converted this a plus bv as rolling resistance coefficient. Here rr is rolling resistance measured in Newton, kr is rolling resistance coefficient. We may get rolling resistance coefficient is 0.0059 for good road surface, 0.18 for loose sand, 0.015 for average type of cars. Here we generally take 0.015 as kr, since we mostly running our vehicle in normal road surface, not even good road surface and not in loose sand. We generally used to run our vehicle in average road surface, so that we take 0.015 as maximum. So rr equal to kr into w. Here w indicates the vehicle weight measured in Newton. Third one is gradient resistance. Here in this picture you can see vehicle moves in 30 degree, 45 degree and 60 degree slope. In this picture 30 degree car is reach the top before 45 and 60 degree slope moving cars. Even we give 9.8 Newton, here we give 13.9 and here 17 Newton, but first car reaches the top before other two cars. Here the angle of slope plays a major role. This angle produces some sort of resistive force towards the movement of vehicle, so we call it as gradient resistance, because the resistive force generated because of the angle of slope, because of the grade we give, so it call it as gradient resistance. This gradient resistance mainly depends on the angle of slope first. If slope angle increases, gradient resistance will increase. I mark gradient resistance as Rg, resistance because of grade Rg. It also depends on the weight of vehicle. If vehicle weight increases, the gradient resistance will increase. For example, let us take this car has 100 kg and 200 kg. If we move the 100 kg vehicle with a force of 9.8 Newton, it reaches the top maybe within 20 minutes. Let us take, if we move 200 kg car with a force of 9.8 Newton, it will reach maybe, let us take us 30 minutes. So the weight of vehicle also plays major role in the gradient resistance. The gradient resistance Rg will be directly proportional to weight of vehicle, and also Rg directly proportional to angle of slope. Sincerely, we can say Rg is equal to W into sin theta, because Rg directly proportional to W theta, we mark sin because it has to move in vertical direction. So vertical direction we can mark it as sin theta. This one is cos theta. I just take sin theta because sin theta is nearly equal to tan theta here approximately. So I take Rg is equal to W into sin theta. Here Rg indicates gradient resistance in Newton, W indicates weight of vehicle in Newton, and theta indicates angle of slope in degree. Thanks for kind listening.